All right, here we're looking at section 8.1 today. We're really starting our new chapter. And as you can see right here, we're going to be graphing these quadratic functions. Really from here on out this semester, we're really going to be just looking at quadratic functions. We're going to start by graphing them. So the next thing that you want to do in your notebook is on your next page. So here you can see I finished up 7.8 with factoring by grouping. Is I'm going to go ahead and put my bookmark on this next page where I have all of my learning targets for my whole unit. So I can see up here, I'm really going to be looking at these first two learning targets today. So I can identify characteristics of quadratic functions, and then I can graph quadratic functions in this form, this ax squared. So right in here, I'm going to put that these are both in 8.1, so I know how to find them and where to find them. So then the first thing we're going to be looking at is this piece of paper right here. This is the different forms and the different features of a quadratic function. So go ahead and fold over this top part. So this is going to be what's going to go in our notebook. So let's first look at these different things. So let's look at the axis of symmetry and what that actually is. So the axis of symmetry is the line, and the big thing here to remember that it is a line that cuts the parabola in half. But this is not just in any half. It's specifically in half so that it's like a mirror image. So when we're writing the axis of symmetry, we have to remember that it is a line. So it's going to be x equals some number, and that's going to be really important a little bit. So let's go ahead and draw that. So here in my notes, I'm going to color this axis of symmetry is going to be pink. And so then over here, I'm going to also draw this as pink on my graph. So one thing I know that it cuts it in half, and here's another point we're going to talk at in the middle, but I see that if I was to fold it this way, it would look like a mirror image of each other. So here would be my axis of symmetry for this parabola. And this right here, this example, if I count from my origin, it's 1, 2, 3, so my axis of symmetry here would be x equals 3. Okay, so now let's look at the vertex and figure out what the vertex is. The vertex is the point, okay, so now we're talking about the point where the graph reaches maximum or minimum. It depends on if it's opening up, so if it's opening up like this one, you'll see this is the lowest point that it gets, but sometimes these will open down, and we'll see that in just a minute, and it will be the maximum. I also like to think of the vertex as where it changes direction. So here I see, if I'm following my graph, that it's going down, 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 down. Ooh, I stop and I've changed a direction, so now I'm going up. So that would be my vertex. So here I'm going to color this vertex something different, a different color, and then I'm going to label that over here in that same color. So the vertex I see is a point, and when I have a point, I have to write it in point form. So my x value was 3, my y value was 1, 2, 3, 4. It was a negative 4. So that's my vertex. The other thing I want you to write in here is that your vertex is the point h, comma, k. Okay? So when we see this, and we'll see this in just a second when we get to vertex form, we're always going to be dealing with h and k. The cool thing to note is if you look over here, that this x value of my vertex and the value of the x in my line of symmetry are the same thing. So I'm going to go ahead and put an h value up in here, so that these two things we can always note are the same thing. Okay, so the y-intercept. The y-intercept is the point, again a point, where the graph crosses the y-axis. Okay, so if we're in standard form, this is C, the letter C, and we'll see that in just a second when we look at what standard form actually is. Okay, so let's go ahead and label that and color it. So my y-intercept, mine's going to be purple. So I know that the y-intercept is where it crosses the y-axis, and my y-axis is always going up and down, so that would be this point right here. And again, it's a point, so it has to be written in point form. So my x was 0, and my y is 1, 2, 3, 4, 5. That is my y-intercept. So now let's finally look at our x-intercepts. And generally, most of the time we'll have 2, but it is possible to just have 1. So the x-intercept or intercepts are where the points where the graph crosses the x-axis. Okay, these can also be known as, these are the things that we've been finding, solutions, or roots, or zeros. All of these things mean the same thing. And we've really looked at that in our last section, and now you're going to be actually mathematically finding a lot of these different things. So again, let's go ahead and label it on this graph, what we can see. So here, I'm going to do this one in blue. So my x-intercepts are where it crosses my x-axis, so I see that that is right here and right here. And again, these are in points, so I have to write them as a point. My x was 1, and my y is always going to be 0 when I'm writing these x-intercepts. And then my second one is 1, 2, 3, 4, 5, comma, 0. Okay, so those are just the big 4 things. Let's move back up to this axis of symmetry for just a second. So when I'm given a graph like this, or when I have, we'll see vertex form here in a little bit, I can pretty easily find the axis of symmetry or the vertex. But how can I find these things if I don't have that information? The way that we find this axis of symmetry and the vertex from standard form, which we'll look at in just a minute, is I take my axis of symmetry is negative b over 2a. This is something that's always going to be true, so we want to make sure that we have this negative b over 2a, negative b over 2a, negative b over 2a. We're going to say it about 1,000,000 times. So let's look at the difference between a couple of our forms. So first we're going to look at standard form. So standard form we dealt with when we looked at our last unit and our polynomials is just our biggest exponent first going down to our smallest. So here we're going to have a x squared plus bx plus c. So you'll see here I've got that a and b that come back over into this formula to help me find the axis of symmetry and my vertex. Okay, so that's standard form. And we're going to be looking at each of these forms kind of individually. So another form that we're going to see we're going to spend a lot of time on is vertex form. And that's going to be a times the quantity x minus h squared plus k. Okay, so you'll see, ooh, there's h and k. There's the point from my vertex. These things kind of definitely all go together, and we'll put them all together here pretty soon. Okay, so that's our characteristics. That's that first learning target, right? So the vertex, the axis of symmetry, and the x and y intercepts. That's all can be found in this one right here. So now we're going to look at the next little piece of this section and look at that second learning target. Graphing quadratic functions in the form of ax squared. So you're going to need this blue one on this not quite full sheet. And we're going to go ahead and fold it just like that. And I'm going to cut mine once we're all done so I have my flaps so that I can really just look at them individually. Okay? So let's go ahead and look at this for just a second. So here I see that if I have the absolute value of a, and remember absolute value just means the positive value or the distance from 0. So if that a value, right, and remember that a is the thing in front of the x squared term, so if that is greater than 1, then the graph is narrower. And I also like to say taller and skinnier. Okay, then the parent function. So here when we're graphing these, we're always going to start at our parent function and then do stuff to it. So that a value is something that I'm going to be doing to my graph. So let's go ahead and graph this. So one of the easiest ways to do is we just pick some x values. I like to pick 0 as an x value because it's nice and it goes away pretty easily. So then let's pick 1 and 2. Let's also, on the other side, go ahead and pick -1 and -2. So if I plug 0 into my equation, and it was 0 squared, which is 0 times 2, which is 0. Let's plug in 1. I have a -1 squared, or I have a +1 squared, which is 1 times 2 is 2. If we plug in 2 here, 2 squared is 4 times 2 is 8. Now let's look at this negatives. So one cool thing is when we're dealing with quadratics is they are like a mirror. So as long as you can find that middle point, that vertex point, then it's easy to go from the other side. So if I put a -1 in, I've got -1 times -1, which is a +1 times 2, which is 2. And if I plug in a -2, I've got that -2 squared, which is +4 times 2, which is a +8. So now I can just plot these points. I have a point at 0, 0. I have a point at 1, 2. And I have a point at 2, 8. So 2, 3, 4, 5, 6, 7, 8. And because this is a quadratic, I can see I have the mirror image on the other side. So then I go ahead and I combine and connect those dots. Okay. And I'm going to go ahead and use a marker to help me see my graph a little bit better, since my drawing is not all that awesome. I want to be able to see it pretty quickly. Okay, so there's that graph. So now let's look at if that absolute value of a, if my a value is little, if it's a fraction, if it's less than 1, then the graph is going to be kind of shorter and fatter than the parent function. Right? So this is called our stretch or our shrink. So this top one's going to be our stretch, and let's go ahead and write these down. And this is our shrink. Okay, as you can see here. Shrinking is also called compressing, so either way. So when we're doing this, I want you to think of if someone was to stretch you, they were to grab you on the top of the head and pull you, you would get a little bit taller and skinnier. So that's what our stretch is. And if they were to shrink you, to put their hand on your head and just push you down and smush you, you'd get a little bit shorter and fatter. So that's what this kind of looks like. So again, I can go ahead and I pick some points. I'm going to pick 0. I'm going to pick 2. Well, I'm going to pick 1 and 2 again, and a negative 1 and a negative 2. If I plug in 0, right, I get 0 squared times 1/2, which is still 0. Let's plug in 1. 1 squared is 1 times 1/2, which is 1/2. 2 squared is 4 times 1/2 is 2. So then I know that this is a quadratic, so I know that these are going to follow the same pattern over here. So I can go ahead and graph this now. And again, I'm going to use marker to help show my graph. Okay, so that's just kind of longer, shorter, fatter, a little bit more chill. Okay, that's what we call a shrink. That is a vertical shrink. Okay, so what's the last thing that we can say? So if that a value is negative, if I have a negative in front, the graph flips. It's called a reflection over the x-axis. So when we're dealing with this a value, it's always a vertical something, right? So vertical meaning up and down. So we've seen that we've stretched it up and down, we've shrunk it up and down, and now we're reflecting it up and down. And if you do this with your hand, this is kind of our up and down. So that's how I can tell. So one thing to note in here is when we're picking these points and plugging them in, remember that those points always go in a parentheses. Okay, so that negative stays out front. So let's look at our same points that we've been dealing with. So if I put in a 0, I have 0 squared, which is 0, and a negative 0 is still 0. 1 times 1 is 1, but a negative there. Let's try 2. 2 times 2 is 4, but then I have to multiply it by that negative 1. And I know that this will follow the same because it's symmetrical across that vertex. So now I can plot my points. And I see that as well. Okay. So it has flipped my graph upside down on this axis. So now here with what we were talking about in this one, with our vertex can be either a minimum or a maximum. Now here's a case where I was going up, 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 and I reached the top, and now I'm starting to come back down. So this vertex in this case would be an example of a maximum. It's the highest point it can ever reach. And we'll get to this a lot. We're going to spend a lot of time dealing with maximums and minimums. Okay? So now we've seen just some of the general pieces, some of the general characteristics of our quadratic, and what we're looking at in a graph once we graph them. And then we're starting to graph these. This is going to take us a while, and we're going to spend a lot of time doing it because we have to graph each piece and kind of figure out what it means and what it's doing to that function and how we can deal with that. Okay? So one thing I want you to be aware of is I want you to always use Desmos to help you when we're graphing, to try and figure out what we're doing and where it's going and how it's being transformed. Okay? So that's definitely going to be a resource that we're going to use a lot. So now just to double check our learning targets, I can identify characteristics of quadratic functions, meaning the vertex, the axis of symmetry, and the x and y intercepts. And then I can graph quadratic functions in the form of ax squared. So we, through these two things, have met both of those. So now it's time to put this into action and go ahead and work on that practice.